Hi, I'm Hannes Erasmus, and I will be talking about human health risks associated with the consumption of metal-contaminated fish from intensive mining activities in a peri-urban region. The use of fish as bioindicators to assess the ecological state of aquatic ecosystems has been effectively proven in the past and is still a preferred monitoring tool to date. Fish as accumulation bioindicators can provide information on long-term exposure to pollutants when compared to invertebrates, while fish as monitoring organisms also provide information on the bioavailability of pollutants, in particularly metals. High metal concentrations in fish can have negative health effects and can alter the embryonic development, adversely affect several metabolic pathways, and stimulate the production of reactive oxygen species. Fish are an important food source for people across the world, with low-income groups particularly consuming fish due to its availability from local water bodies and thus providing a less expensive protein source. However, communities that consume contaminated fish on a regular basis are chronically exposed to toxic pollutants, such as organic compounds and metals, which may cause increasingly genotoxic, non-carcinogenic, and carcinogenic health risks. These fish are normally not only contaminated with one pollutant, but rather with a mixture of pollutants which may enhance the toxicity. It is estimated that 1.6 million people live in formal and informal settlements on or directly next to mine dumps in South Africa. These people are not only exposed to contaminated dust, water, and soil, but the consumption of fish from contaminated water bodies can pose adverse health risks. Local subsistence fishers from rural areas in South Africa, and more specifically from the study area selected for the present study, generally target three fish species. These species are the non-native common carp, Cyprinus carpio, the indigenous sharp-toothed catfish, Clarias garipinus, and the indigenous Mozambique tilapia, Oreochromis mozambicus. These three species are selected as indicator species for the present study due to their abundance in South Africa and in the study area, their resilience and general association with sediments, as well as their significance as food source to people. It was therefore hypothesized that fishes from the highly impacted impoundment Bospoort Dam, downstream of the mining and urban activities, will accumulate metals at higher levels when compared to fishes from the reference impoundment, upstream of the mining activities. It was further hypothesized that fish from the impacted areas will consequently pose a higher health risk to people that consume these fish. Worldwide, South Africa is the main producer of platinum, with 73% of the total global production in 2019. The majority of these production activities occur within the Rustenburg area, located in the Bushveld Igneous Complex, or the BIC. The Hacks River is the main arterial drainage system in the western limb of the BIC, and this catchment is situated on diverse geology, with some of the richest mineral deposits in the world, with minerals such as chromium, copper, nickel, and platinum. These rich mineral deposits resulted in intensive mining activities, and some of the world's most productive platinum mines are located on the banks of the Hacks River. This river system is not only impacted by intensive mining activities, but receives industrial and urban effluent from an increasingly growing city of Rustenburg. The upper reaches of the Hacks River catchment end up in Olifantsfontein Dam and has limited anthropogenic impacts, mainly small-scale agricultural and game farm activities. The impoundment situated in the lower reaches of the Hacks River, Bospoort Dam, collect water from various anthropogenic impacted sources that include industrial, mining, and urban effluent, as well as nutrient loads from treated and untreated sewage effluent from the city of Rustenburg and its surrounding informal settlements. Before field sampling, the necessary permits and ethics were obtained. 3 surveys were completed between May 2017 and November 2018, where in situ water quality parameters were taken, and water and sediment samples collected in triplicate from each site for metal analysis. The selected 3 fish species were also collected from both impoundments for metal analysis. In the lab, concentrations of arsenic, cadmium, copper, lead, nickel, platinum, and zinc were determined by ICP-MS, while concentrations of chromium were determined by graphite furnace AAS. The appropriate univariate statistics were used to determine the significant differences in metal concentrations of the different matrices. The metals, nickel and platinum, were significantly higher in the water from Bospoort Dam than those of Olifantsnek Dam, where concentrations of cadmium, copper, nickel, and zinc exceeded the threshold of several water quality guidelines. In the sediment of both impoundments, the concentrations of arsenic, chromium, and nickel exceeded the consensus-based threshold effect concentrations, while concentrations of chromium at Olifantsnek Dam and concentrations of nickel at both impoundments exceeded even the probable effect concentrations of the consensus-based sediment quality guidelines, indicating a high level of concern for sediment-dwelling organisms. In the present study, concentrations of arsenic, chromium, and nickel were 4, 5, and 2-fold higher compared to normal upper crust values, respectively. However, these high metal concentrations originate from parental rock and are released into the river and might become available for aquatic organisms. On the other hand, intensive mining, urban and industrial effluent may contribute to an additional anthropogenic increase in metal concentrations over the already elevated background concentrations. The Mozambique tilapia accumulated significantly high concentrations of arsenic, chromium, copper, nickel, platinum, and zinc compared to carp and catfish. The present study was the first to assess the levels of platinum mining-derived metals in fish occurring in the impacted region, as well as the potential health risks associated with fish consumption. The anthropogenic impact was evident in fish samples, where concentrations of arsenic, chromium, nickel, and platinum were significantly higher in the area of Bospoort Dam in comparison to Olifantsnek Dam. All of these metals are associated with the intensive platinum mining along the Hacks River. These metals are taken up by the fish from the environment, as well as potentially through the diet, which leads to accumulation in the tissues and could potentially have detrimental effects on organisms that consume this fish. No information on actual fish consumption in the Hacks River catchment is available, and therefore an estimated human health risk was based on adults of 60 kilograms consuming a 150-gram portion of fish twice a week that may be at risk of exposing themselves to adverse health risks. However, individuals who are more susceptible and sensitive to chronic exposure to metals include pregnant women, lactating mothers and their infants, as well as children. According to the Human Health Risk Assessment, the concentrations of arsenic within these fish species are not acceptable for safe human consumption. Although only the concentrations of arsenic exceeded the safe human consumption levels, it is important to keep in mind that a mixture of different metals occur within these fish species that might potentially pose an even greater risk to people who consume fish. Other pollutants, example, organic compounds, in the aquatic system may be present, which can also increase the risk of fish consumption. Arsenic ingestion might also not only pose several cancer risks, but also various other health issues such as diabetes, pulmonary and cardiovascular diseases. Also, adverse pregnancy outcomes and infant mortality are associated with arsenic. The risk associated with consuming Cyprinus carpio, Clarias garappinus, and Oreochromis mozambicus from Bospoort Dam was respectively 20, 90, and 10% greater for those than of Olifantsnek Dam. Although the fish from Olifantsnek Dam could also pose a health to humans, health risk to humans, the probability remains lower due to the strict catch and release recreational fishing protocol implemented at this impoundment. On the other hand, the risk posed by consuming fish from Bosboer Dam is paramount, as local subsistence fishers sell fish to local communities. With the rapid growth of informal settlements in the proximity of the Hacks River, and with an increase in rural populations living in poverty, an increase in the demand for cheap nutritional protein supplements is already established and will only increase in the future. This will result in an increase in the frequency of consumption of fish from Bosboer Dam and most probably the frequency of health issues associated with the chronic exposure of different metals. Although no HQ values could be calculated for platinum, it might potentially pose a risk to human health. A study found that platinum exposure can occur in humans via ingestion and inhalation. The authors concluded that platinum chloride formed complexes with stomach fluids. In another study, it was found that the LC50 values of platinum were in the same range as cadmium and chromium. Additionally, chicken embryos accumulated platinum at a higher rate in the brain compared to the liver, due to the lack of a fully developed blood-brain barrier. Humans also do not have a fully developed blood-brain barrier at birth, and platinum can potentially accumulate in the brain of newborns, which can induce neurodevelopmental effects in babies. To conclude, metal concentrations in the BIC are naturally high. However, anthropogenic activities such as mining, industrial, and urban effluent contribute to even higher metal concentrations. Fishes from the Bosboer Dam accumulated significantly higher metal concentrations. And although only arsenic exceeded the HQ, platinum can also pose a potential health risk. This highlights the human health risk associated with the consumption of contaminated fish within this intensive mining region, and highlights the need for studies to assess the full extent of human health risk associated with living in close contact with mining regions. I would just like to thank the following institutions and persons who made this research possible. Thank you.